Hello everyone. Today I have an incredible project to share with you, the AQI predictor, a powerful tool for monitoring and predicting the air quality. So this project was developed as a dedicated efforts for EcoTech, the hack for sustainable tomorrow by Team SRT. So my name is Suchit and other two team members are Rutik and Tejas. So what is an AQI? AQI or air quality index is the number that tells us how clean or polluted air is in the certain place. It considers things like tiny particles, ozone and other pollutants. The score ranges from 0 to 500. The higher the number, the worse the air quality. Keeping an eye on the AQI is super important for understanding how the air pollution affects our health. So do you know how we usually know the air quality? We use manual stations but they can't cover everywhere and sometimes the information isn't instant. The air pollution is a tricky thing. It's affected by weather, which makes it predicting accurately pretty tough. But here is the cool part. Machine learning algorithms can shift through ton of data and find the hidden clues. This helps us to predict the air quality way better than the old methods. It's just like shifting from traditional maps to Google Maps. Problem statement. So we are tackling a big problem, air pollution, which can harm our health and the planet. Our goal is to create a smart tool that uses computer algorithms to give us real-time information about how clean or the polluted air is. This helps us to come up with an effective plan to make the air better. Data requirements for AQI prediction. To make precise predictions about air quality using ML, we use a bunch of information. This includes past air quality readings, weather data like temperature and wind, where the place is, and other important details. The better and more the data we have, the better our predictions will be. This is the dataset or link that we have used currently in our project. Machine learning algorithms that we are used for AQI prediction. First is bootstrapping. Random forest uses a technique called bootstrapping, which involves creating multiple random subsets of the original datasets with replacement. Each of these subsets is called bootstrap sample. Then is decision tree. For each bootstrapping sample, a decision tree is trained. However, these trees are not regular decision trees. They are called the base learners and are typically shallow trees. The tree is trained to predict the target variable based on the random subsets of feature for each split. This randomness helps reducing overfitting. Then ensembling of trees. After creating multiple decision trees, usually hundreds or thousands, each tree makes its prediction independently for given input. Then last is aggregation. The predictions from all the individual trees are then combined or aggregated to make the final prediction. In regression tasks, the most common aggregation method is to take the average of the predictions from all the trees. This averaging smooths out individual errors and tends to give us more accurate results. Applications. We have discussed this earlier too, but these are the four major applications. The first is the health management. Predicting air quality enables the healthcare facilities to prepare for potential spikes in respiratory illness, ensuring adequate staffing and resources are available to treat patients. Then is urban planning and policy implementation. Cities can use air quality prediction to implement timely measures such as traffic restrictions or industrial regulation to reduce the pollution level and safeguard the public health. Third is environmental regulation and compliance. Regulatory agencies can enforce emission standards effectively by using real-time air quality predictions. And last is public awareness and precaution, providing the public with accurate air quality forecasts and empowering individuals to take precautions such as avoiding outdoor activities or wearing masks on days with poor air quality, thus safeguarding their health. So this is our project. So let's evaluate the air health for certain parameters. Let the parameters be random, anything, but it will be less Then just clicking on predict AQI button, you can check the air quality. So it's showing good. So now let's consider some higher parameters. So let's check what it shows. So it's showing unhealthy. So as I stated earlier, the higher the number, the lower the air quality. You can just click on this button, evaluate air health, and set the parameters and get what type of air health is on that particular day. So this is about section of our site. This is our team, and you can contact us by just submitting the form. So this is how our project is, and you can just click on evaluate air health and set the parameters and check whether what type of air health is today. It is pretty easy and simple. So conclusion, using ML to predict the air quality can make a big difference. We can do this by using really smart math and a lot of information about air, like how clean it is and what the weather's like. But we need to be careful about getting good and fair information and making sure we understand what computer is telling us. So working together with everyone involved is super important to make this idea really work well. So thank you.